Now, building on Dr. Iba's insights, particularly that second principle of transparency and explainability, our next speaker is going to take us deeper into technical side. And Joseph Jacob will share with us more insights on explainable AI and interpretability. Because as Dr. Iba showed us, we can't have fairness without transparency. So we need to understand how this AI system makes decisions, not just what decision they make. So in this light, I introduce to you Joseph Jacob. Is a data scientist and analyst with passion for explainable and ethical AI. He recently completed his MSc in applied data science with distinction at Teesside University, where his research focused on predictive modeling and model interpretability in sports analytics. So Joseph is going to, dive deeper, to give us more insight about what Dr. Iba has, just shared with us. So please welcome Joseph Jacob on Explainable AI and Interpretability. Joseph, over to you.
Thank you very much. I will just quickly share my document. Thank you everyone for your presence today, and we'll be talking about transferring the explainability techniques from the project which he has talked about, which is the sport analytics, into fintech, to see if there is a way we can use the same explainability in the fintech sector. And also, what ways can this help to tackle bias in AI system? So majorly we'll be talking about AI in fintech, then going to fair lending issues where we've had explainability being a key issue in the fintech sector, and also talking about the explainability techniques that was used and how it can be used in fintech. SHAP, which is the major explainability, will also be taken into context here before driving basically into bias identification using this transparency technique. So with that, I'll quickly jump in so that we won't waste too much of our time. AI in fintech. So there was a survey. Actually, surveys usually are taken regularly, 2 years, 3 years, by the Bank of England and the Financial Conduct Authority to understand how the fintech services in the UK, how they actually make use of AI in their processes. In this survey, 72 of the UK financial fintech say they've been using or developing. Actually, the figure was 65 of them say they've already started using it, while 14 are still developing AI in their system. This also increased in the 2024 survey to around 85, meaning more people are incorporating AI into their systems, which calls for understanding where there are risks. And the survey also showed the risk area in terms of the consumers, the customers, and also the company. In the customer area, they say data bias was one of the key risks, while lack of transparency was and interpretability was an issue with the companies, because you need to understand how your models are making decisions. To talk about bias and how we can actually tackle bias or identify bias in a system, there are several techniques. One of them, which has been mentioned, or two of them, the explainability, also the fairness metric, has been mentioned. Also, counterfactual testing are being done to surface bias. And what does counterfactual do? It's actually a theory that will say would the outcome change if a sensitive attribute was different while everything else remained the same? So you change just one of the features or one of the attributes, but leave other things. Will the prediction change because of that little change? So it's monitoring those changes that could occur while just tweaking something. So it's able to show if there's a bias by tweaking a data. But the main focus for today will be on explainability too. Because of that, we'll also be taking a look at issues in terms of fair lending, where there have been issues in explainability. So there are two cases here that have been projected. We talk about them briefly. The first one, the DFS issues, was actually based on an Apple Card issue in 2019, where people say that the Apple Card was sexually discriminating, meaning it offered women lower credit limits than men, despite having similar credit worthiness, meaning they have the same borrowing amount, how much they be given back, how their age, and several other factors. But they wanted to see why they were having this different outcome, despite the fact that they have similar characteristics in terms of their credit worthiness. So the DFS decided to make findings. They decided to make research, and after doing that, they discovered that although it might seem that people are having that issue, but the major reason was because there were some people who were using probably their spouse card, and they felt because they are using their spouse card, they should have the same credit score, which wasn't supposed to be the case. Everybody should have individual credit limits and credit worthiness. And because of that, they discovered that there was actually no fair lending violations. And Apple had to also give better explanations to the DFS team. Majorly, they didn't want to reveal all of this to the public because of privacy issues. While in the second issue, it was an allegation also by the Student Borrower Protection Center that the Upstart lending model also was resulting in educational redlining. It was based on the fact that they said graduates from colleges and universities that has history of having Black people in them were actually being offered a very high interest rate compared to those that were situated in white predominant institutions. Because of this, they have to also perform different findings, checks to understand how their model worked, and if there was actually this issue in the data. Although they realized that they made use of education and employment data, but there was no correlation between all of those and the issue in play, which was the fact that Blacks were being given higher interest rates. Although more checks are still being made, but that is the present situation, that the model does not actually discriminate. But what we can take out from this is the fact that the lack of transparency, which means because people don't actually know why they are receiving a low credit limit, there's no explanation. This actually can lead to people thinking there's an actual discrimination, even though the model was not discriminating, but because it was not being explained, they don't know why they are being given that credit limit or credit score, which takes us to why explainability actually matters. Just from what we've talked about, it leads to a lack of transparency, which can look like discrimination. Trust, when people don't understand why they're getting low score, they begin to question your system. And also, another reason why it matters is because explainability is not only about the technical aspect, it's also about the social aspect, as you can see. If they've not taken time to ensure that they should be able to explain, then they would know that socially people are going to also feel some type of way about how they get their limits and their credits. They're going to be able to say, even though you've said you've accounted for it in your technical area, you should be able to explain to people because they want to know about it. So the bigger question says, if a model is accurate but not explainable, can organizations trust it? Which takes us to the model that was created. This is in the football industry, which is a different industry, but which has the same problem, which is explainability. The aim of our project was actually to identify most important metrics contributing to a football performance. So if they are going to win a match, what are the major features that contribute to it? In this kind of model, it's a high-stake model, which means predictions matter. You should be able to predict at a very high rate. And also, explainability also matters. Why is this prediction making this prediction? Why has it made this prediction? What are the top factors that made it to predict a win or a lose? At the right-hand side, you see the different models that were used in our experiment, and logistic regression actually performed best amongst all of the models. But the issue with logistic regression was it gave a global insight, meaning you cannot know why a specific team is actually winning. And if you can't make that, then you cannot explain to that team why you made that prediction. It's only able to make a general prediction based on the old training that's based on the old data set. This is why it is performing this way. But based on a specific team, it won't be able to make that prediction. That is why we made use of SHAP. SHapley Additive explanation, which is transparency in AI. Dr. Iba mentioned about SHAP when she talked about transparency. And what does SHAP do? SHAP actually assigns each features. When you train your model, there are several features. So it takes each features and assign a specific score to it, meaning this is number of percentage this feature actually adds to your model prediction. It combines every possible combination where that feature is not there. How will the model perform? When the feature is there, how will it perform? So it uses to gauge how all those features actually impact, and it gives it a value. That value is called SHAP value. The SHAP value quantifies every impact of the inputs. For example, you can see there, it can say feature 1 adds 0.15 importance, while feature 2, 0.09. So you can see that feature 1 actually adds the highest. Similarly, you can also have negative importance, meaning the negative says the more you have that data, that feature in your data, the lesser you are going to get the prediction you're looking at. So how does this help? How does SHAP help our models? Our modeling are majorly black box model. When you predict, you use predictive modeling. They are black box. What does black box mean? Meaning you do not know how that model is predicting. You just know that it takes in data and it helps you predict a score. Let's say Middlesbrough Football Club is playing against Swansea Football Club. It takes the data and then says Middlesbrough Football Club is going to win. But you don't know how it actually made those predictions. What features did it say, did it make use of to say that is why they will win? And then explainable AI like SHAP, which helps to get those features, turns a black box system into a white box model. White box model is just a model that you can explain now. You've been able to predict. Now you can also explain why this model is performing this prediction. SHAP in football. This is an example of a SHAP explanation in football. At the left-hand side, you can see different figures from top to bottom. You see the ones which are at the top are actually higher, meaning they have higher importance. They add more importance to predicting that game. You can also see that there are some that are negative, some are positive, that is left and right. Those ones that are negative, the left, means the more you have these figures in your data, the more that team are likely to lose that game. While the one at the right shows that the more they have that data or that feature, the more they are likely to win that game. And the data by the right also is a data from a picture from Power BI, incorporating all the features into. Remember, we said we were trying to know how to explain each games, not just the general game. So the picture down there, you can filter. For Middlesbrough, you can know what were the features. For Swansea, for whatever team you want to check, you can just filter through and to show you the features for those teams, so you can know why the model predicted for each teams. In credit scoring, remember our major purpose today is to see if you can move the same explainability from football and sports into the financial system. In a scenario where a customer applies for a loan and receives a credit risk like of medium, they've seen this, but they do not know why they had the medium risk. SHAP can help you. Instead of just giving only the score, SHAP actually breaks this down to why the model has reached that decision. And this is just an example, just like what I showed earlier on. The positive area, the negative areas, someone who is having an income of stable income for the past 3 years, we have that reducing the risk, meaning there won't be high risk for that person. So someone who also has missed his payment, meaning that will be increasing the risk of you giving that person a loan or a credit. So this all shows you an example of how SHAP will explain. It will show every feature and why it has made that prediction. We will also be looking at bias using bias identification using SHAP, because we've been able to explain, but how does this influence bias identification? So that's the next step. So bias identification in credit scoring using SHAP. This is actually, what we have here is actually an experiment that was performed by Ramon and Renato in 2021 in Brazil. It was just a model to understand the mechanism of racial bias in a modeling system. After they predicted the credit default to see probability of if people are going to default, that is, if people are not going to repay a loan, if they collect a loan, with these people, is there a high possibility that these people will not repay this loan? They were able to predict that and get the explainability. The explainability is what we have by the right with different features. But after they started predicting or checking for several other people, they realized that the CEP3 there was giving varying figure. Sometimes it is positive, while sometimes it is negative. So they decided to take a good look at it. So the CP3 is actually the first 3 digits of the Brazilian postcode. So it's related to different areas in Brazil. When you have the postcode, it actually relates to different locations in Brazil. So they decided to check those values and plot it on the Brazilian map. They noticed those at the northern parts had high risk, meaning the CP3 increases the risk of them not getting loan. While those are the southern part, the CP3 increases the possibility of them getting that loan. So this was baffling, and they decided to get the census data from for Brazil to be able to see an estimation, the proportion of people who have said they are not white using that same CP3 code. And then the top, the image at the top is the one they plotted, while the image at the bottom is the one that they plotted from the data gotten from the census. The upper one is from the SHAP, while the bottom one is from the census data. So what they noticed in the census data also was that more people that said they are not white are the northern part, while the less people that said they are not white are the bottom, meaning southerners are more of white and the northerners were more of the darker skinned people, which automatically showed that there is a geographically definition using the CEP3, which also carries a racial information. They call them proxies, as Dr. Iba has mentioned. These are just data that carry some information, even though they are not supposed to, but in a way they've carried an information that relates to something else. So it's just a postcode, but it carries a racial information, which automatically is making that data biased to a set of people. So this is a way where explainability and transparency can actually help you notice bias in the system, where you understand why it is making the prediction, and also you see whether there's actual bias from that system, from sports to fintech. So why does this transfer, that is the transfer of explainability from the sports work that has been done to fintech, why does it actually make sense? Number one, it helps with credit risk decision making, like we've mentioned, where instance level explanation can be made. You can easily tell someone that your credit was declined because of these 3 behaviors, and you list them, list the percentage of how it has impacted it, and they understand why. So when next they're applying for a credit or a loan, they know what to work on if they've become better in that aspect, and they'll know their possibility of getting that loan. It also helps in debugging, which it also helps in debugging, where you can identify patterns, just like we're seeing right now, biased proxies, unstable features, and also features that are also contributing to disparate impact. It removes the black box modeling pressure. We talked about black box, because when you don't know why a model is performing a prediction, you wouldn't even want people to question you, because when they question you, you don't know the answers to give. And lastly, regulatory or decision accountability. That there is no case that will come up which you won't be able to come out to say why, because you have the explainability to these, or the explanations to these questions. So to conclude, I would say fair AI is actually non-negotiable. And when we can explain a model's decision, we can trust them, definitely. And this also leads to us building a much more better product, better team, and a much more better product and better team, and a better financial system. Thank you very much. This will be all from me today.
Thank you very much, Joseph. That was very, very insightful. And from the chat section, I can see a lot of, questions coming in from the chat section. A lot of people have various questions, about this fairness and, the explainability of AI. And like I said, thank you for, the great presentation. That was insightful as well. So we're just going to move straight, to the question and answer section, because time is not so much on our side, and we don't want to keep everybody waiting for too long. So, and also for Joseph, another question for you is from the explainability side, can tools like SHAP help identify these bias sources? Joseph, you have 30 seconds for us, please.
Yes, they can actually. If you've seen from the presentation, one of the experiments that was shown there actually identified bias using SHAP. I'll just reiterate that again, so maybe you didn't get that earlier on, or probably the message was sent before that was being said. First, the SHAP actually helps to explain. Then from the explanation, you can see where there are variabilities when you're predicting for several type of, because we have different characteristics, whether by age, by location, men and women. So when you check for these people, you can see if your model is actually using, if there is a disparity, there's a variation in your prediction in terms of explainability. If there is, then you can still check how your SHAP affects those areas. Then you can see if there's a negative or positive. From there, in the data, the CEP3, which was the location, was given the people at the north, which was the people who were more darker. They were having high risk. They couldn't get loan quickly than people that were at the bottom, because it was using CP3, which was the location. So the location was actually giving a bias in terms of race, because some people were at the north, while some people were at the similar thing. You can take that into a place like Nigeria, whereby you have northerners, you have southerners, you have easterners. When the location actually is biased, you can easily see that probably maybe the north people are getting more of the loans. And then even though it's using location, but it has already become biased. Somebody who is at the north, who is not supposed to get that loan, might get that loan more easier than someone who is at the south, because the model is already biased.
Thank you very much, Joseph. I think that's really, really great. And so I think currently we have a lot of questions in the chat right now, but because of time doesn't permit us, so every other questions that we have in the chat will definitely get answers from Dr. Iba and Joseph himself, and then we'll try and relate all those answers to those questions via email to all our audience. Thank you very much for those questions. They are really, really insightful. So